Cheerleading is a vibrant yet dangerous sport. Over 4 million cheerleaders in 31 countries demonstrate their best jumps, stunts, tumbling, and dancing in 2-minute and 30-second routines. This short amount of time makes it crucial that a cheerleader shows only their very best abilities. But how can one ensure perfection in such dangerous skills such as tumbling? Well, physics can surely help. It explains the science behind every move a cheerleader makes. Analyzing the physics of a tumbling pass, such as the tuck, which is one of the most fundamental skills, could actually impact how a cheerleader executes them. What is a tuck? Well, put simply, it's commonly called a back foot. But there's more to it than that. It can be done from a standing position, going forwards, or going backwards. Let's start by looking at a simple standing tuck. A tuck is an excellent example of the conservation of angular momentum. Angular momentum measures how much an object is rotating while accounting for its size and shape. Angular momentum is measured by velocity times inertia. That being said, you can change your moment of inertia by changing your radius r, because inertia is equal to mass times radius squared. When you bring your knees in closer to your chest and decrease your r, your inertia decreases. Based on the conservation of angular momentum, a cheerleader's momentum is constant throughout a tuck, meaning as you pull your knees in closer inward and decrease your moment of inertia, your angular velocity must increase. This greater speed will mean faster spinning and it's easier to land on your feet instead of landing on your butt. A common mistake cheerleaders make in their tucks is throwing their head backwards. This can be problematic because you want a vertical direction in order to maximize your height and therefore air time in order to complete full rotation. Tucks can also be done in the forward rotation, commonly called a front tuck or a punch front. It's important to raise your arms in this because potential energy is equal to mass times gravity times height. There's also a point in your tuck in which kinetic energy is equal to potential energy, and kinetic energy is equal to 1/2 times your mass times your velocity squared. Therefore, when you increase your height by raising your arms, your potential energy increases, and your kinetic energy increases, and your velocity increases. And as we already proved, a faster tuck needs more time for a full rotation. Slink tucks can be combined at the end of a running tumbling pass, typically a round-off, or after a round-off back handspring. You start by running because it increases your velocity and therefore your momentum, which will be helpful later in the tumbling pass based on the conservation of momentum. According to Newton's third law of motion, every action has an equal reaction. This can be applied because the more force you exert on the ground, F sub A, the greater the force it will exert on you, F sub N, once you include gravity, mg, in the equation. This will cause you to have a greater height in your tuck. As you can see, cheerleading is much more complicated than meets the eye. It requires skill, strength, and consistency. I hope you enjoyed this video and thank you for watching.